Okay, let's get started. Good morning and happy Wednesday. So what I have on the agenda is the notes. We need to finish that graphing tangent and cotangent functions. And then I also posted an Edmodo quiz yesterday that's not due until Saturday at midnight because I know you still have stuff with APs going on, and I just wanted you to be able to focus your attention on those important exams. Okay, so we were looking at these. So graphing tangent and cotangent. The essential questions, number 62 is what is the domain of the tangent function and how does it impact the graph of the tangent function? And 63 is why does the cotangent function have vertical asymptotes? So remember we filled these out last class, and those notes are the videos up with last class agenda and also in the library. And I think the hard copy is there too. So example one, graph the parent function, state the domain and the range. So we did the tangent last time. We're going to do the cotangent this time. And then I wanted to roll the dice and come up with some functions, and we'll graph those. We'll describe them, graph them, and talk about the domain and the range. Okay, so the so this is example 1B, and we are graphing the parent function. And then we're going to state the domain range. So it's the parent function, which means there won't be any transformations for us to describe or talk about. So we've got f of theta equals the cotangent of theta. And I wanted to remind you that cotangent is the cosine of theta over the sine of theta. So in graphing this, our first step will be to set b theta minus h equal to 0. Now this is the parent function, so we don't have any of these transformations, so theta just equals 0. Our second step is that f of b theta minus h equals 0. So we'll just plug in the value that we have. So now remember, the cotangent, as I was saying, is the cosine of 0 over the sine of 0. Now, the cosine is asking for the x-coordinate of this angle, and the sine is asking for the y-coordinate of the same angle. So the angle 0 is right here on the positive x-axis, and the x-coordinate is 1, and the y-coordinate is 0, which means we'll have a vertical asymptote. So I'm going to pause because I feel like I might be going too fast. So can you give me a thumbs up when you're ready? Okay. Great. And all of this makes sense? You can turn off your mic, you can turn on your microphones and ask me questions, or you can chat them. Either way. All right. So if we're good there, our third step is to come up with 4 additional points. So now for the tangent function, we went from negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. But in this case, what we want is to get a range of the x values compared to the y values. So the y values, vertical asymptotes will occur at 0, and then we want to use pi over 4, pi over 2, 3 pi over 4, and then pi, so that we get those vertical asymptotes on either end. So for the cotangent, our usual theta will go from 0 to pi. And then we'll just have, we don't have any transformations here, so this will just be f of theta, our y values. So in this case, we'll have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So those will be the usual theta for the cotangent function. So we saw when we plugged in 0, we got a vertical asymptote, which I'm just going to abbreviate VA. Now, I'm going to color code this a little bit, so people looking back on these notes later, if they're out for their AP test, it will make some sense. So if we have the cotangent of pi over 4, remember that's the same as the cosine of pi over 4 over the sine of pi over 4. So the x-coordinate of this angle over the y-coordinate of the angle. So this is 1 over the square root of 2 over 1 over the square root of 2, which is just 1. Okay, for this angle right here, the cotangent of pi over 2 is the cosine of pi over 2 over the sine of pi over 2. So remember from the unit circle that pi over 2 is that vertical, straight up, positive y-axis angle. So the cosine there is going to be 0 because, as I said, it's on the y-axis. So that means it's a y-intercept and x has to be 0 over 1, which is 0. Okay, then this angle right here, the cotangent of 3 pi over 4, that's the cosine of 3 pi over 4 over the sine of 3 pi over 4. So remember the cotangent, 3 pi over 4 is going to be that angle in the second quadrant, that 45-degree angle in the second quadrant. 45 degrees above the negative x-axis puts it in the second quadrant. So this will be negative 1 over the square root of 2 divided by 1 over the square root of 2, which is negative 1. How are we doing so far? Okay? Give me a thumbs up if everything's all right, or you can ask me a question or chat me a question. Okay, so Violet, do you have a question? Oh no, you're good. Okay. All right. So the very last thing that we'll do will be this one. So the cotangent of pi, again, that's the cosine of pi over the sine of pi. The cosine is negative 1, but the sine, again, because that's right on the negative x-axis, so that's going to be an x-intercept, means that the y is 0, and that gives us a vertical asymptote. So that's that. Is that okay? So I posted these graphs to Edmodo. They're in the library, but they're also on, I think, Mondays, the post about Monday's class. So I'm going to count by pi over 4s on my x-axis, and I think I'm going to count by 1/2 on my y-axis, just so things aren't too squinched together. Okay, so I'm going to move this together so we can see them all on the same screen. So we said 0 was a vertical asymptote, so I'm going to use my turquoise pen that I always use for asymptotes. And pi is an asymptote. So I'm going to put this over here. And also negative pi is an asymptote. And the way that I know that is the pattern repeats itself. So the asymptotes have to be evenly spaced. So even though we didn't find that coordinate, we can predict that there will be one there. So graphing the points I have in the table. So pi over 4 is positive 1. So that's right here. Pi over 2 is 0. So that's right on the x-axis, or I guess that's the theta axis. 3 pi over 4 is negative 1. And so it's going to approach the vertical asymptote to the left, and it will approach the other vertical asymptote here on the right. So I can repeat this pattern in this space here on to the left of the origin. So this one should be here. We have a point here, and we have a point here. So again, going this way and connecting with a smooth curve here, and then approaching the asymptote over here. And that's the cotangent function. That's the parent function. The domain and the range we still need to do. So I'm gonna glue this down really quickly so I stay organized. So that's that part. Questions about the graph? Okay, have you finished your graphs? Are you ready to move on? So give me a thumbs up if you're ready to move on. Perfect. Okay, so notice the domain is going to be chopped up because of these the vertical asymptotes. So we're going to use our same interval notation with the unions. So the domain, there's a more concise way to put it, but you'll learn that in pre-calculus. So we have what? Negative pi to 0 and 0 to pi, and we can tell pi to 2 pi. So then union dot dot dot. Right, so we're creating a pattern that people can understand. And we're just linking these areas in between the vertical asymptotes with unions. Also, because we do have vertical asymptotes, notice these are parentheses and not brackets. And then the range will be very familiar. It's negative infinity to positive infinity. Okay, is that all right? So give me a thumbs up if that's okay, or you can ask me your question, chat me your question. Good. Violet, everything okay? Okay, so I propose for our second example, we will describe the transformation. I'll graph the function. And we'll state the domain and range. Okay, so let's see what happens here. We'll call this part A. We'll do a tangent one and then we'll do a cotangent one. Oh, the worst nightmare. Okay. So I don't want that to be, okay, we'll say that's 3, and horizontal shift will be plus pi over 2, a vertical minus 6. Okay. So here we go. So we have f of theta equals the tangent of 3 theta plus pi over 2 minus 6. Okay, so remember that when we have a b and a b that's not 1 and an h that isn't 0, we kind of need to factor out the b. So I'm going to do that. So we'll have 3 times theta plus pi over 6, and then minus 6. So that way I can see what b is, and I can see what h is without the influence of b. All right. So far, okay? So here's our description. So I noticed that b equals 3, and that is a horizontal shrink by 1/3. I noticed that h equals negative pi over 6. So that's a horizontal shift left pi over 6. And I noticed that k is negative 6, which is a vertical shift down 6. So let me know if all of that is what you expected and makes sense. Okay, good. All right, great. Okay, so our next step, we have to figure out how to graph it. So the first thing that we will do, we'll set b theta minus h equal to 0, as always. And this step kind of confirms what we said about the horizontal shifts and transformations in our description. So if I start with 3 theta plus pi over 2, I set that equal to 0. I get 3 theta equals negative pi over 2, and theta equals negative pi over 6, which is what we set up here. So that's it's a nice thing to have that affirmed. We're on the right track. What we predicted would happen is definitely what's going to happen. Okay, so for our next step, we could plug in this negative pi over 6 into the function, but we know from our work in the first step that that's going to equal 0. So we'll just say the tangent of 0 minus 6. So remember, the tangent is the sine of 0 over the cosine of 0. So the y-coordinate of the angle on the positive x-axis is 0 over 1. So all of that simplifies to negative 6. Okay. So the third step, we'll make our table of 4 additional points. So here we've got our usual theta for tangent. We'll have our thetas to graph that will be impacted by the horizontal transformations, and then whatever those vertical axis coordinates are. So we said negative pi over 2 for tangent, negative pi over 4, 0, pi over 4, and pi over 2. Okay, so we've found these coordinates out in our first and second step. So this will be negative pi over 6, and this turns out to be negative 6. Sorry, there you go. All right, so based on that, now we'll go about finding these values. So we have 3 theta plus pi over 2 equals negative pi over 2. So I'm just repeating the first step that we did, only instead of setting this equal to 0, as we did in the first step, we'll set it equal to this first value in our table. So when I subtract pi over 2, I get 3 theta equals negative pi over 2 minus pi over 2, which is negative pi. And so I find that theta equals negative pi over 3. Hopefully that's what you expected to have happen. Otherwise, you could ask me a question. All right, looking for this value here. We have 3 theta plus pi over 2 equals negative pi over 4. When I subtract pi over 2, I'll have to have common denominators. So negative pi over 4 stays the same because that's the larger denominator. And then this will be minus 2 pi over 4. So this will combine to be negative 3 pi over 4. And then when I divide by 3, I kind of have a choice here if I want to cancel the 3 that will be in the denominator with the 3 in the numerator. I think that I'm not going to do that. So this will be negative 3 pi over 3 times 4 is 12. Now, the reason I'm not simplifying it is because I think that at some point we will want to have all the same denominators, so it will be easy for us to choose the increments on our horizontal axis. So I don't think I want to reduce that just yet. Okay, so for pi over 4, I need another piece of paper. All right. So for pi over 4, I'm going to say example 2. Okay, so we'll have 3 theta plus pi over 2 equals pi over 4. Again, we'll need to have common denominators. So 3 theta equals pi over 4 minus 2 pi over 4. So 3 theta equals negative pi over 4, and theta equals negative pi over 12. And our very last value here is 3 theta plus, where's our function at? Plus pi over 2 equals pi over 2. And when we subtract that, we get 3 theta equals 0, which means theta is 0. Okay, so we'll find our y coordinates here. So I'm going to find the cotangent, I'm sorry, the tangent. The tangent of negative pi over 2 minus 6. So this is the same as the sine of negative pi over 2 over the cosine of negative pi over 2 minus 6. Now keep in mind the sine will be -1, but the cosine will be 0. So that gets us a vertical asymptote. Because this portion of the expression overpowers this portion. So the -6 just kind of gets washed away in the like tsunami. You can think of it in that way. So this is a vertical asymptote here. The next thing we have to figure out is for the negative pi over 4. So that's the tangent of negative pi over 4 and then -6. That's our function that we're working with. So again, the sine of negative pi over 4 over the cosine of negative pi over 4. So down here in the fourth quadrant, this will be -1 over the square root of 2 because the y coordinate is negative there. And the cosine, the x coordinate is positive. So, whoops, sorry, that's just -6. And so this will be -1 minus 6, which is -7. So -7 here in our table. Then we have the tangent of pi over 4 minus 6, because that's the next value in our table. So again, this is the sine of pi over 4 over the cosine of pi over 4. So we can tell that this will be 1 over the square root of 2 over 1 over the square root of 2. Pi over 4 is in the first quadrant, so both the x and the y are positive. So 1 minus 6 gives us -5. So this will be -5 here. And lastly, the tangent of pi over 2. The same thing happens. The sine is 1, but the cosine is 0. So in this case, that'll be another vertical asymptote. Okay. So that's our table. I'm going to pause there because I want to check in and make sure that you don't have any questions or this explanation's satisfactory. So give me a thumbs up if you're good to go. Okay, perfect. All right, so as I mentioned before, I want to change these so that they're all the same denominator so that we can actually have a little better sense of what we're graphing. To choose the horizontal axis increments. So the thetas to graph, I'm just going to kind of rewrite the table for the bottom 2 rows. So we've got -pi/3 there, but notice our largest denominator is 12. So I'm going to multiply this by 4/4. So we'll have -4pi/12, and that was a vertical asymptote. Our next one will be -3pi/12, and we got a -7 there. Then -pi/6 is what we have in the middle. We're going to make that -2pi/12. And this is -pi/12, -5, and this is 0, and the vertical asymptote. So that's that feels a lot more humane to be able to choose our horizontal axis increments, and also we can see that the pattern is there. Like, oh, okay, that's what we were going for. So that's also very affirming that we've been choosing the right stuff. Okay, so let's see. So it looks like pi/12. So if we go by 1, 2, 3, 4, that will work. So pi/12, 2pi/12, 3pi/12, -pi/12, 2, 3, So we have vertical asymptotes here at negative 4 pi over 12. We have one on the vertical axis. And just recognizing that pattern and continuing on with it, we'll have one over here as well. Okay. All right. So negative 3 pi over 12. It looks like we should probably count by 2's here. 2, 4, 6, 8, 10. So negative 3 pi over 12 is negative 7. So that should be right here. Negative 2 pi over 12 is negative 6. So that's here. And negative pi over 12 is negative 5. So here's the first one. So that negative 6 really pulled everything down. We should have a point here, and one here, and one here. So here's our second curve. So there's that. Questions about that one? All right, sorry that we had to make the table twice, but it does make those choosing the increments on the horizontal axis much better. I realized I was struggling with it the other day. I don't remember if it was your class or a different class, but because I was trying to do it in my head, and why would you do that? Okay, so the domain here, let's see. So we have, okay, so if we say negative 4 pi over 12 to 0, okay, so dot, 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 union, negative 4 pi over 12 to 0, and from 0 to 4 pi over 12, and that should be what? 4 pi over 12 to 8 pi over 12? Union, dot, dot, dot. Does that make sense, Kings? Okay, it won't hurt my feelings if you have questions. And then the range is our old pal, negative infinity to positive infinity. Of course, parentheses everywhere, parentheses in the domain because of the vertical asymptotes, and parentheses in the range because you can't actually include infinity. You can only approach it. All right, so we feel okay about that? Instant replay, any part of it? Do you have questions? Okay, so give me a thumbs up if you're ready to roll the dice for a cotangent problem. Okay, all right. So let's see what we get. Vertical stretch, vertical shift. That's one we already have. That's one we already have. Okay, horizontal. All right, so let's see. -1, just a reflection. That's nice and easy. Negative pi over 4. Okay, not terrible. +5. Well, all right. Okay, so here is example 2b. Here's our function. So f of theta is negative cotangent theta minus pi over 4 plus 5. Okay. That seems fairly humane. So let's see. First of all, the description. So I noticed that a is -1. right? So that's going to be a not a stretch, a reflection over a reflection over y equals 5. Is that what you expected to have happen there? We've got h equals pi over 4. This is a horizontal shift. Right, pi over 4. And the last thing we have is that k equals 5. This is a vertical shift up 5. Okay. All right, so our next steps. Let's figure out b theta minus h equals 0. This is fairly obvious, I think. Theta minus pi over 4 equals 0, or theta equals pi over 4. Again, that just confirms what we said in our horizontal shift, so that's nice to have that affirmed. The second step is we'll plug that in and see what we get. So this is the opposite of the cotangent. Remember, if we plug this in, we'll just get 0. So I say, let's skip the head to the, what's that expression? Cut to the chase. Okay, so remember that cotangent is, so this is the opposite of the sine. Oh, just kidding. Just kidding. That's tangent. Cotangent is the cosine of 0 over the sine of 0 plus 5. Okay. So this will be, that's going to be 1, but that'll be 0. So this will just be a vertical asymptote. Okay. Which is what happened the last time we did the cotangent. So I have every confidence we're on the right track. So our third step is to come up with the 4 additional points. So 3 for the curve and 2 more for the asymptotes. So our usual thetas for the cotangent are different than for tangent. It's the top half of the circle, so quadrant 1 and 2. Our thetas to graph, or the thetas that have been impacted by the horizontal transformations, and then whatever our vertical axis coordinates will be. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. So we've already used 0. So this turned out to be pi over 4. And this turned out to be a vertical asymptote according to the first 2 steps that we've done here. That's how we got those values. So let's color code this again. So in order to find this value, we have theta minus pi over 4 equals pi over 4. And that gets us, I think I'm going to try to do these this way. That gets us theta equals 2 pi over 4. I'll write it like this, which is pi over 2. Okay. The next step, we have theta minus pi over 4 equals pi over 2. So that gives us theta equals 2 pi over 4 plus pi over 4. I'm going to check my work. I feel like I'm not totally paying attention. Okay. Okay, I agree with that. So I have to get common denominators here because I'll be adding fractions. So the pi over 2 becomes 2 pi over 4. Good. Okay. So we've got 3 pi over 4. Okay. So I agree with that. All right. For our fourth value, we've got theta minus pi over 4 equals 3 pi over 4. So when I shift that to the other side, change the sign, and I'm left with theta equals 4 pi over 4. Again, I know I want to reduce that to pi, but I would like, I'm going to switch this one to 2 pi over 4 so I can see the pattern and just a little bit more clear. Okay, so theta minus pi over 4 equals pi, or theta equals 4 pi over 4 plus pi over 4, which is 5 pi over 4, and that confirms our hypothesis. So right now, let's just switch this one to 2 pi over 4. 2 pi over 4. So now we can see the pattern, and we know that we want to count by some pi over 4. So let's come up with those y coordinates. So the pink one here, we have what? The opposite of the, I'm going to draw a line here so we know. The opposite of the cotangent of pi over 4. And then we have a vertical shift up 5. So this will be the opposite, the cotangent of pi over 4. The, okay, this is the cosine of pi over 4 over the sine of pi over 4, and then plus 5. So this is the opposite of 1 plus 5, so that gives me 4. I went through that really quickly, so I'll give you a second and I'll explain it again. Okay, so the x-coordinate of pi over 4 is 1 over root 2. The y-coordinate of pi over 4 is 1 over root 2. This minus sign makes it, so that would be 1, and then the minus sign makes it negative 1. So pi over 4, remember, is this 45, 45, 90. So the x-coordinate and the y-coordinate are the same. Okay, so for our next feat, we've got negative cotangent of pi over 2 plus 5. And remember, this is the opposite of the cosine of pi over 2 over the sine of pi over 2 plus 5. But the cosine is the x-coordinate of that straight up angle is going to be 0. So this will be 0 plus 5 or 5. Okay, next up we've got the opposite, of the cotangent of 3 pi over 4 plus 5. So this is the cosine of 3 pi over 4. Now remember, this is the second quadrant where the cosine is negative, but the sine is still positive. So this will be negative, let me go through this. The opposite of negative 1 over root 2 divided by positive 1 over root 2 plus 5. So this part itself would be negative 1, but that makes it positive 1. It was 1 plus 5, which is 6. Okay, so if we're okay there, say example to be continued. The very last one we have to figure out is the opposite of the cotangent of pi plus 5. And this is the opposite of the cosine of pi over the sine of pi plus 5. And again, you probably can recognize the pattern here. The cosine of pi is -1. So this would be the opposite of -1 over 0 plus 5. And that gives us the vertical asymptote. Okay, so you can write that in right here. Okay, and let's come up with our graph. We'll talk about the domain and the range, and then we'll be all set for today. Looks like we want to count by, we've got 5 pi over 4 here, so what do you think? I guess, should we count by 2 pi over 4 so we can get this in here? I mean, I guess we could count by 1.5 pi over 4, but somehow that seems exceedingly painful. Okay, so I'm going to say, let's have this all on the screen together. Let's go by 2 pi over 4, or 6 pi over 4, 2, 4, 6. Okay, and I guess we're counting by 2's here as well. 2, 4, 6, 8, 10, -2, 6. Okay, so our vertical asymptote we said is pi over 4. So it will be halfway, because this is 2 pi over 4, so 1 pi over 4 is halfway between. So I kind of have to estimate that a little bit. Not too bad. And then we also said 5 pi over 4. Oh, these are going to be crazy, but okay. I guess this isn't really crazier than this quarantine thing we have going on right now. Okay, so that looks like that's, so if we count this as 1, so that would be 2. So that's off. So right here we should have 1. Does that make sense? So a halfway and then a whole 1 and then another half 1. And then that means we should have another one right around here. Okay. So we'll get to see several branches of this. So that's kind of, I don't know, that's kind of worth it. All right, so pi over 4 is a vertical asymptote. 2 pi over 4 is at 4. 3 pi over 4 is at 5, which is here. And 4 pi over 4 is at 6. So here's our points. So that means this one should be here, and we should have a point here, and we should have a point here. So here's our first curve. Whoa. It's pretty gorgeous. Okay, so we should have something here and here and here. I think I don't want to write over that increment there. And then we'll have here and here and here. And again, same thing. I don't really want to write over the increments. There we go. So put something here and here. It's pretty fascinating. All right. Oh, there's a question. Sorry, I didn't see that. Let's see. Oh, okay. All right. Well, they'll be, okay. So these, you can tell her that the notes will all be on Edmodo. I'll put all the examples because I'm rolling the dice, and so there'll be multiple examples for people. Yeah, the technical challenges. Well, it's not locked, so if she wants to log back on, she can. But we're almost done, so either way. All right, so the domain here. Okay, so dot, 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 the union. So do you want to go with here? So that should be negative 3 pi over 4, comma, pi over 4, and pi over 4 to 5 pi over 4. Is that what we said in our table? Yes, 5 pi over 4. Union 5 pi over 4. And how many are we adding here? 4. So that should be what? 9 pi over 4? Okay. Just double checking. All right, and then our range, again, negative infinity to infinity feels like a breath of fresh air after that domain we just figured out. Okay, are we okay there? All right. Great. So, like I said at the beginning of class, there's a quiz on Edmodo. It's multiple response. So there's the description of the function in there. There's the domain and range, and then you have to click on the attached PDF file to see the graph options. So, but that's not due until Saturday at midnight. So whatever AP stuff you have going on, you can finish that all up before you have to take that. Other than that, if we're good, I will see you on Friday.